Okay, so for problems 13, 14, and 16, we need to find the missing angles. And once again, we're going to use the SOHCAHTOA. Now, what we do is, so this angle, and they could use a question mark, but I'm just going to call it X for now. Actually, I'm going to call it theta. All right, so theta is just a Greek letter, and it's kind of like the X, but for angle measures. It's what we often use. All right, so in this case, when I look at this theta, I have the 12 is the opposite leg of my missing angle, theta, and the 39 is the adjacent leg, or the leg right next to it. So what I would do, so I'm using tangent, right? Remember SOHCAHTOA tangent. So I would say tangent of theta is equal to 12 over 39. And so then when I do this to find the angle, I just do the inverse tangents, right? So theta is equal to tan minus 1 of 12 over 39. And this is going to give us our angle measure. And so I'm actually turning on the calculator right now. And in the calculator, I would type in 12 divided by 39 equals, and then second tangent, and I get 17.1. And so my theta is 17.1 degrees. And just to go back over that, so I would do, in the calculator, I would do 12 divided by 39 equal sign, second, and then the little yellow part that says tan to the minus 1. And in all calculators, you should look for this whatever tan, sine, cosine, tan with the minus 1, and that's called the inverse tangent. All right. Okay. For this next one, once again, they call it a question mark. I call it theta. This theta, I have 17, which is my adjacent side, and 26, which is the hypotenuse. So this is adjacent and the hypotenuse. So in this case, I'm using cosine. So cosine of theta is equal to 17 over 26. So I would do theta is equal to the inverse cosine of 17 over 26. And so once again, in my calculator, I would do 17 divided by 26 equals, and then second cosine button, which is the inverse cosine button, and theta is equal to 49.2 degrees, according to the calculator. All right. For the third, 16, all right. Now my theta is the opposite side over the hypotenuse. So we're using sine of theta is equal to 32 over 40. Now I can't simplify it, but honestly, since I'm using a calculator, it's not necessary. So then I would just say theta is equal to the inverse sine of 32 over 40. And so in the calculator, I would type in 32 divided by 40 equals second inverse sine, and I get 53.13. Remember that from our first? So that would round to 53.1 degrees, like this. And that's it.